So our next talk is by Joe Stubbs from TAC. He's going to be talking about enabling science with functions as a service, new features, and usage of the Abaco platform.
Okay, awesome. Thank you very much. Yeah, so my name is Joe Stubbs. I'm at TAC, and I'm going to be talking about a functions as a service platform that we've been developing there called Abaco. So just a brief acknowledgement, this is funded by the National Science Foundation, and I also want to thank my colleagues and co-authors on the paper here. So just a quick overview of the outline. Gonna just briefly talk about functions as a service, what that is, and introduce the basic usage of Abaco itself. Talk a little bit about the use cases that we see for science gateways. Say a little bit about what we've been doing with Abaco over the last year and a half or so in terms of new features, and then kind of close with a few science highlights from the usage. So I think there was a nice presentation in the first talk about using AWS Lambda as functions as a service, and probably lots of people are familiar with the concept, but I wanted to kind of give a quick overview for those who may not be familiar. So with functions as a service, basically what you do is you create this small unit of computation called a function. You can think of this as like a little program, and you register it with the FAS platform. Then once it's registered, you can send requests to the platform, instructing the platform to execute that function with certain inputs. So in the end, these functions end up running on the remote platform, right? Not on the developer's laptop. And that's where this term serverless comes from, right? It's the developer isn't providing any servers, but of course there's servers involved on the platform side. So with Abaco, which stands for actor-based containers, what we have is a functions as a service platform where the functions are packaged as Docker containers. So you build your functions in Docker containers, and then you interact with Abaco over HTTP. So Abaco incorporates the actor model of concurrent computation, which is why we refer to the functions as actors. I'm not going to go into detail about the actor model itself. It's not really necessary to know anything about that to use Abaco. But Abaco started as a prototype in late 2015 and then became funded by the National Science Foundation in 2017. So we've been in production a little over 2 years now, and we've done almost 1 million executions, about 24 million seconds of total function runtime in that time. So yeah, so the basic usage, what you do is you take some program, some little computation that you want to do, and you package it up in a Docker image. You push that image to the Docker Hub or any other publicly available image registry. Then you register that image as an actor with Abaco, and that's just a post request to one of the endpoints inside the Abaco API. Once it's registered, Abaco will create for you a URL assigned to that actor. And then you can send that actor what we call messages by making a post request to the URL assigned to the actor. Now, once that happens, once you've made a post, internally what Abaco is going to do is it's going to queue that message in a message queue assigned to the actor. So for each message, eventually what Abaco is going to do is it's going to run a container from the image associated with the actor, and it's going to inject the message data into the container. It's going to supervise the execution. And so while it runs, it's collecting resource utilization, container logs, other kinds of data, and exposes that through other endpoints. The other thing to say about Abaco is you can update actors, you can delete them, and you can also share actors with other users at a specified level. So there are kind of two primary types of use cases that we see for Abaco. So on the one hand, you can just kind of think of Abaco as a task queue abstraction, right? It's just tasks as a service. Any kind of background or asynchronous processing that you want to do, you can send, you can package as an actor, and you can run it on Abaco. So this could be anything from various things you need to do at account initialization when new users sign up for your gateway, to pre-processing and post-processing of files and other kinds of data that are coming into the gateway. So that's kind of on the one side. On the other hand, you can actually do scientific analysis, like was mentioned in the first talk. You can actually run AI image classifiers and AI workloads, other kinds of analyses directly in Abaco. So the left side is really kind of defined and implemented by the CI experts, the web developers, and the programmers building the gateways. And the other side is traditionally defined and implemented by domain experts, the researchers using it. And so what we kind of think is cool, what we're hoping for, and what we've kind of started to see with some projects, is a sort of convergence of these two use cases, right? You can see with data pre-processing and post-processing, steps, you can combine that with analysis to form sort of complete pipelines. And that isn't to say that all the analysis has to happen on Abaco, right? Abaco actors can make calls to submit jobs to traditional HPC systems and other kinds of platforms, but you can combine all of this into sort of a complete pipeline. And so Abaco provides this platform where domain experts and CI experts can collaborate together. It's language agnostic in the sense that any container, any Docker image can be used. And there are multiple patterns for combining the components from tightly coupled where actors send messages directly to themselves to more loosely coupled where things are triggered by events. And so, yeah, we see that as these things get integrated, it tends to reduce time to solution because there's this coherent pipeline. So this is the architecture for Abaco. I won't go into the details, but just to mention that we have a front end with web services. We have a back end set of workers, and then we have a persistence layer made up of MongoDB and RabbitMQ. And then we have this autoscaler that essentially watches the queue links and starts and shuts down workers based on which actors have messages that are queued up. So we've been working on a number of features since the initial production release of Abaco. That was, in January of 2018. So the autoscaler itself is new. You can also manually scale your worker pool for a given actor that you have permission for. But we have this autoscaler. We've added support for doing synchronous executions. So typically when you send a message to Abaco, it just queues it up and it runs it at some time. But you can actually say, no, I want to run this as a blocking call. And so the whole execution will run as part of the HTTP request, and the response will come back with the result of the execution. We have added support for actor networks, a lot of different features for these complex networks, including an event subsystem, this thing that we call aliases, so that you can change actors in a network, change their definitions without impacting the other actors that call it, and then config objects for configuring whole sets of actors all at once. And then we've also added this global search, which is pretty cool. It gives you exact and fuzzy match search across all of our primary collections, including all the logs. There is a study. It was actually published in 2020, but performed pretty much in 2019. Where we did a kind of deep analysis of the Abaco performance. It's published in GCC. I won't go into detail here, but we scaled it up to 100 nodes, 100 M1 medium nodes on Jetstream. And we did a mix of a bunch of different workload tests, including matrix multiplication and SHA-256 hashing. So we got about 19 teraflops of performance, and the big upshot was that the autoscaler was really negligible compared to manual scaling. So that was cool. So just a brief word on Abaco compared to other platforms. There are a lot of other functions as a service platforms out there. Obviously all the commercial clouds have them. There are a lot of open source ones as well. Abaco is open source. It is funded by the NSF. It is hosted at TAC. And it is free to use for researchers. So that is one of its distinguishing features. It does incorporate this actor model, which I didn't really talk about, but we think that that's really useful for building these networks, these more complicated pipelines of integrated functions. And then it targets the research computing case, right? So we're really trying to be a platform for gateways and the types of workloads that they run. So we integrate with TAC resources, things like the POSIX interfaces to high performance TAC storage, and also Jupyter notebooks for scaling functions from there. And with the next release of Abaco, what we're hoping to be able to enable is for institutions to run a subset of the Abaco components, just the workers, and leverage the AI, the API infrastructure hosted at TAC, and be able to run Abaco functions on premise at your own institution. So that's coming up next. So yeah, this is just some of the details. We have several projects using it. Some is just kind of a basic task queue, including our new UT Austin COVID-19 modeling consortium. Some are using it more on the sort of research side as an execution platform like DesignSafe and GenApp and Cyverse. And then we do have a couple of projects that are starting to use it with these really large networks, including the Synergistic Discovery and Design Environment, which is a DARPA-funded project, and then NUID out of NASA JPL. So yeah, that's it for me. There's a link to the docs on Read the Docs and to the GitHub project if you're interested in checking any of that out. My email there is there, so happy to answer questions. And yeah, if you want to learn more, feel free to join our Slack team as well there. Thanks.
Awesome. Thanks so much, Joe, for sticking to time. Yeah, so we've got close to 3 minutes for questions. If you have any, please put them in the chat.
I do have a question, and I missed a little bit at the beginning. So is this a TAC specific service? And so the containers and the actors actually run on TAC, is that correct?
That's correct. Yes, exactly.
Okay, thank you.
Yeah, so it's TAC specific, but really, the people using it are all over. Lots of different collaborators from different institutions. So it's running on TAC infrastructure. For now, we have some organizations that are interested in standing up, parts of the system and running functions on their infrastructure. So hopefully by this time next year, we'll have a few examples of that as well.
So it's, in a way, that was a really neat talk. In a way, this is a gatewayless gateway, right? This is just the insides, correct?
Yeah, exactly. That's so nice that you brought that up, because one of the inspirations for this was these sort of serverless gateways, where you could have a gateway that just lived on Google Drive, right, or Dropbox, right? Or any really content delivery system where you just had static files, and the idea there was you just bundle up some JavaScript and CSS and image files, and you can have a pretty functioning gateway. But you need an API, or you need something where you can, usually you need something where you can queue up backend, asynchronous tasks. And so we thought, with this, you could eventually realize this idea of this truly serverless, distributed on Dropbox gateway. And so we do have a couple of folks in our web team that are kind of looking at doing something like that. It's not quite ready yet, but that's our hope.
Very cool. Is this the API that your Tapas gateway uses, or this is a different beast?
Yeah, thank you for bringing that up too. That's a great question. So we are integrating this with the newest version of Tapas. So it will be there will be a functions endpoint inside Tapas v3, the version 3, and it will just be this. It'll really just be Abaco. We actually just pushed that to our kind of beta for v3 a couple of days ago. So you can combine it with the streaming API that's there in Tapas v3 and some of the other APIs. So yeah, that's kind of the relationship. It'll ultimately be just the functions API inside Tapas.
Great, thank you.
Thank you.
Great, those were really interesting questions. I do have a final one. We're at 3:15, so the next 15 minutes is kind of a mini panel where I'm hoping to have, I guess, everyone here answer some questions. Well, the 3 presenters answer questions, but maybe I'll start with Joe and then kind of move on to the others. So this is more of, I guess, Abaco specific question, but maybe more general as well. So these functions that you're designing, so what are sort of the I guess, the design patterns or the constraints, because you have things like side effects. I don't know if you have to worry about side effects that these containers are going to be introducing, and especially when you have the whole actor model with the network, how do you ensure that the next, maybe the next thing, next function in the chain sort of runs only when you expect it to run? So what are some of the design patterns that someone might need to follow if they're design functions?
Yeah. Okay, that's a great question. So these, yeah, these are generally speaking not pure functions. They do have side effects.
Mm-hmm.
Um, some, you know, one of the big common use cases is that we have a, you know, somebody has some big directory of data files, you know, and they just mount them as POSIX, you know, mounts into the container, and they do some churning through that stuff, right? So, you know, there's all kinds of side effects happening there. Um, the patterns, so the patterns are kind of two, I would say two main ones. There is direct messaging. So, I have actor one, and, you have actor two, and I don't, actor two doesn't run unless I call you. And I say, look, I did this, it's done, it's ready. And I send you a message, and now you run. That's kind of a direct, kind of tight couple. And then the loose couple is events, right? So when something happens in Abaco, like an execution starting or an execution finishing, it's an event.
Mm-hmm.
And there are mechanisms essentially for having those events trigger other functions, trigger other, basically you can send, you can tell the system, I want this actor to receive this message whenever this event happens.
Mm-hmm.
And so that's kind of a loose coupling. You say, oh, that actor must have just finished, so that means it's, it's my turn to do whatever.